Welcome to Device Drivers for Servers Part 2. I think we're going to do this in 3 parts in order to keep the video size down to small chunks. I'm going to go ahead and close Server Manager. We're going to talk about plug and play in this particular video. I'm going to go ahead and open up the Device Manager. I can just type Device Manager. I can also type the file name devmgmt.msc. That would also bring me to the Device Manager. Or I could just click on the right click on the Start menu, and I should find the Device Manager up in here. There it is, Device Manager. Any of those will get me here, and I can see that I do have one device driver that is in trouble. We will deal with that in the third video. But for now, I'm going to go up to one of these. In fact, I think I'll choose network adapters. These are in categories, and I can choose different views here, but right now it's in devices by type, which is the default. I'm going to choose network adapters, and I'll just choose the top one of these, this Intel MT desktop adapter. I'll right click on that and go down to Properties. I'm going to go to the Details tab, and I'm going to drop down this device description and choose Hardware IDs. Now what you see here are a series of numbers that specify the device ID. And by the way, this is the best way to find the numbers that you need when you're looking for drivers out on the internet. I've seen people Googling all sorts of things about the devices, trying to find what they are using this name over here, and it just doesn't work very well, but these numbers can get you right to it. These are in decreasing order of specificity. In other words, these are very specific matches, and as you go down, they get more and more generic. I could get very much deeper into how that works, but I'm not going to for the purposes of this video. But this is a very specific match up here, and you see we've got a vendor number 8086, and then a device number 100E, and then a subsystem number 001E, and so on. Revision 02. This is a very specific device number. Now, what's going on here is that if I plug this device in, Windows has a set of services that are running that is just looking for new devices. When it discovers a new device has been plugged in, it pings, if you will, that device and asks for the device ID. Once the device ID is reported back to Windows, it will look for an INF file, that is a device driver installation file that matches this device ID. Once it finds that, there are registry entries as to where to look for drivers that relate to that INF file. It will now look in those folders, such as the drivers folder and the driver store folder, for device drivers that are in association with that INF folder. It will then install those drivers, and by installing the driver, it means it makes a registry entry for that driver, and it also installs the resources for that driver. Now, by resources, let's look at this Resources tab. What we mean are there are 4 system resources that it could install. Not every driver uses these. In fact, some drivers don't use them at all, and I chose this one particularly because it does use some of these. A memory range, which means that this particular device is going to set aside this area of memory for itself, and other programs should not use this area of memory. It may also set aside an I/O range, which is, you can think of it like a little inbox between the software and this device for it to use. Then it can also set aside an IRQ, and IRQ means interrupt request, and this is a number that is assigned to this device that the CPU will recognize, that this device can send to the CPU to interrupt it. Let's take as an example the keyboard. You want the CPU to respond when you press a key on the keyboard, no matter what else the CPU is doing, so that you have control over that CPU. Say you press the escape key and you want the CPU to stop doing whatever it's doing. So the interrupt request is a message or a signal sent to the CPU to make it respond. It used to be in very old days, before we had plug and play, that many devices there were only a few interrupt request numbers, and different devices would conflict in those numbers. But now there are like 256 of them, so we have plenty of interrupt request numbers, and we don't really have conflicts anymore with plug and play today. So in this case, this network card has been assigned an IRQ number of looks like hex 13. So the fourth one, there are only 4. The fourth one is this particular device doesn't use, and that's a DMA, or direct memory access channel number, and that is a number used in order to send information directly between the device and memory without having to go through the CPU and tying up CPU time. So those are the 4 system resources that a device might use that are set up during installation of that driver. Now, IRQ is the only one that the Microsoft MTA wants you to know about. So that's an important one to understand what the IRQ does. Well, that's it for plug and play and how it's associated with drivers.